Good morning, everyone. I want to introduce myself. My name is Bobby SULISTIO FEBRIAN, and my nickname is Bobby, so you can call me Bobby. So I am from University of Indonesia. I graduated from UI in 2014, and I've been 9 years experiencing in teaching national and international curriculum, especially for Cambridge. And then I experienced in teaching a lot of different students from different backgrounds. Most of them are from national, but some of them are expatriates, yes, such as from India, China, and also from South Korea. And also my main subject in teaching is math and physics. Yeah. But I experience teaching for IGCSE level for math and also IGCSE for physics. So I think that's enough. So I think we can go to our topics right now about electric current. The basic concept of electric current is basically the same or similar to how the water flow in the river. You know that electric current is basically the flow of current, the flow of electrons. Right? But there is a special law that manage or that guide how the electrons can flow from one place or one terminal to another place or terminal. So basically, so I'm gonna define what the electric current is. So the current is basically the flow of electron. So in a circuit, the flow of electron depends on the difference in potential, or we call this like voltage. But in some other book, they mostly call potential as potential difference, or we mostly say electric potential energy. So what is the meaning of electric potential energy and how it relates to current? So basically, how the current flow from one place to another place is very similar to how the water flows in the river. Okay, so let's say I'm going to give you two different examples of, let's say this one is how the river flow. So this is the first river, and this is the second river. So I'm gonna go for this river first. Okay. So can you imagine that this river flow from one place to another, but can the water really flows through it? Well, the answer is that since the surface of the river is the same or at the same level, so no flow rate will be measured. Why? Since water cannot flow on a flat surface. Common sense, right? But let's compare with this. Can water flow from this place A to this place B? Well, basically, using our logic, and the water can flow. Why? Since there is the difference in height. So I'm going to name this delta H. Okay, so at different level, the flow rate of water can be measured. It's simply because of the difference in height, right? You can also use your own observation using pipe or pipeline. If you make a the similar or the same level, the water, and you put water onto it or into it, the water will not flow to the other side. If you make it tilt like this, so the water will flow. Okay, simple. So my point is that delta H here is basically, or is the best analogy to the voltage. The voltage is also another important aspects in electric current. So the current itself is the first important one. The voltage is the second important one. So we can take a direct conclusion that voltage and current are in the same proportion. Or we can say that current proportional to the voltage. What does this mean? Proportional. Proportional means that if the current is greater, then the voltage would be greater. Simple concept. But if the current is decreased, then the voltage will decrease. None. There is simple explanation of current. So if so I'm gonna go back again to the water, the water analogy. So if you set a higher level here, then the water will flow faster. Very easy, right? And very easy to understand. So that means if you make the voltage greater, then the current will greater, since the water will flow faster than the first one. If you make it lower, like this, different color, this very lower, this very low high, then the water will very slow, very slow rate. So this is the best analogy to understand how the electric current flow inside the cable or inside the wire. Okay, so there would be two important aspects. Voltage, I'm gonna ask again, is there anything else that can be done or can be counted on this concept? Well, there is one more aspect that will affect how the current will flow. The last thing, but not the least, is resistor or resistance. What is resistance? I'm gonna go back again to the flow of water. If try to imagine this. If the water flow in the river, is the water flowing smoothly or not? What do you think? Well, naturally, if you go to the real river in the mountain, you will find that there will be so many rocks, big rocks right in the middle of the river, or probably some small rocks in the river banks, right? So, and also probably there will be a, block of woods, or probably something stranded inside the river, or under the river. So it is blocking, the flow of water, or it's blocking the water. So it affects the speed of water. So the same thing happens inside the current or inside the wire. There is a resistance inside the wire. So what is the cause, the main cause of the resistance? It is the collision between atoms. Collision between atoms inside the wire. As you know, wire is made of conductor, which is metal. Inside the metal, there is so many electrons, and it's not pure. It's not pure. So inside the wire itself, there is so many, we call that impurities, right? Impurities. So the meaning of impurities that it's not pure. So the water or the current which flows through the wire is sometimes blocked by so many things. And one of them is collision between atoms, or even the collision between the cable itself, the surface, the cable surface. So resistance is blocking. Resistance. So the greater the resistance, the slower the current. So what do you think about this? They are inversely proportional, right? Inversely means that if one thing is greater, the other thing is lower. So we can conclude here that the resistance, the greater the resistance, the slower its current. Or we can say, and slower as also less. The less is current. Current and resistance is inversely proportional. Current is inversely proportional to the resistance. What is the meaning of inversely proportional? Inversely proportional means that if the current, I'm gonna start with the resistance. If the resistance is greater, the current will be less or lower. If the resistance is lower, then the current will be greater. So we've got three important aspects in electric current. Current itself, the voltage, and the resistance. So how do we connect these three? I'm gonna put a simple formula here, right? Since current and voltage is proportional, so I'm gonna symbolize I proportional to V, and current is inversely proportional to the resistance. I is 1 over R, so this one is proportional, this one is inversely proportional. So we can conclude that V equals to, or we can also say in Ohm's law, so we're going to direct you to that law. So R is basically V divided by I. This is basically Ohm's law. So the resistance is inversely proportional to I, or current. That's why I put the I in the lower part and V on the upper part. And you can modify this into many formulas, such as V equals to I times R, and also I equals this is the basic of Ohm's law. Now I'm gonna move to the circuit. How do we arrange the resistance if there are more than one resistance? Okay, let's go to the next subtopic. The next one is about arrangement of resistance. So basically there are two different arrangement in resistance. The first one is called series circuit or series resistance, and the second one is parallel. But I want to discuss about how the resistance is arranged in both different types. Okay, the first one is series resistance. So in series resistance, I'm just gonna simply draw like this, right? And name this R1 and R2. So if the flow, or if the current flow through this cable or this wire, so this wire will be applied by the resistance, or there will be a blockage from R1 and R2. So along this wire, the speed of current will stay the same. So and logically, we can say that the R total, the resistance, the total resistance of this series can be derived as R1 plus R2. Why is it added? Since there are double blockage that being applied to the current. So that's why it is added, or it is the total sum between R1 and R2. Okay, so what is the other effect of this statement or this conclusion? And the other conclusion is that the I total, the current, the total current that is flowing through this cable or this resistance is equal. As the consequence of the total sum of resistance, the current will stay the same. So since there is no branches, so the current will still flow at the same amount. Okay, now let's go to the V. Yeah. What is the effect on voltage? So this is the effect of the resistance. It is basically R1 plus R2. For the current, it is the same. How about the voltage? Yeah. The voltage, yeah, in each of these resistance, yeah, will be different. Okay. Why? Yeah. Look at this. So if I total equals to I1 equals to I2, yeah. So how do we derive from this statement? We can go back to this. I equals to V divided by R. Yeah. It's based on our basic formula. Okay. So I can derive I total into V total divided by R, and I1 equals to V1 over R1, I2 equals to V2 over R2. From this statement, yeah, we can say that the total V, so since RT equals to R1 plus R2, so you can put the similar, or we can derive the similar conclusion that Vt equals to V1 plus V2. Done. So there are three conclusions from the series circuit. And first, that the R total, or the total resistance, is summed or added. Yeah. R1 and R2. How about if there are more than two resistance? You just add them up. If there are three different resistance like R1, R2, R3, then you sum them up. R1 plus R2 plus R3. If there are six, you sum them until R1, R2, R3, R4, R5, and R6, so on. Okay? And also, the total current which flow through this circuit will be the same. Why? Since there is only one loop. One loop doesn't change anything, doesn't change the speed of flow. And since the resistance is already summed. And also, yeah, the V, yeah, the total voltage will be equals to V1 plus V2. So V1 means the voltage on R1, V2 is the voltage on R2. There are, I'm going to check this three important formulas. So this is what we're going to do in the exercise. But before that, I'm going to go to the parallel circuit. For parallel circuit, so it's kind of different. Yeah, since the main loop is branched out into two different loops, but then it unites again on this point. So, yeah, in common sense, yeah, the main current I, yeah, is branched out. Okay, so we can derive from I total equals to this is I1, this is I2. Why? Logically, yeah, if there are two pipes from the main pipes, if there's water flow through the main pipes, then at the end of a point, it was branched out into two directions. So logically, and the water will flow in both, right? In both directions. So we can derive that I equals to I1 plus I2. That's the consequence. Yeah, I equals to V over R, V1 over R1, V2 over R2. So if we can take this, the R, so you can say that 1 over RT equals to 1 over R1 plus 1 over R2. This is our main formula for parallel. So the total resistance will be derived using this formula. What is the meaning of this? The meaning of this is that the total resistance in parallel circuit is always less than the greater resistance. Since this formula, this calculation is decreasing everything. It's decreasing both the R1 and R2. So using parallel circuit, so in conclusion, if we're using parallel circuit, then the total resistance will be dropped. Yeah. Since this calculation can lead to the lower value of resistance. It's always less than both resistance, both value of resistance. I'm gonna highlight. So, yeah, so far we can compare both examples here that the series circuit will make the resistance greater. Why? Since you sum up the total, each resistance. On parallel, the total resistance are less than both or than the included resistance. So it's very simple. And then, okay, so I'm gonna give you 3 different formulas for each. So for parallel, this is the first consequence, that I equals to I1 plus I2. And the second one is this. The third one would be the voltage. The voltage is the opposite of the series. In the series, if you want to find the voltage, total voltage, you have to sum the voltage on each resistance. In parallel, the value of V total equals to V resistance 1 and the V resistance. These 3 are the main formula parallel circuit. If there are more than 2 resistance, then you can add this up. If there are 4 of them, so you can add this into 3 or 4. 3 to 4, 3 to 4. But make sure that your calculation is correct. Okay, let's move on to the next subtopics. I'm going to discuss about electric power. Since in energy, in physics, when we deal with energy, it has to be deal with the power. Since there is also a thermal power, or kinetic power, and also potential gravitational power, and also work. So they are all related, but only different version of energy. This time it is called electric power. But before I start, I'm gonna ask you, what is the definition of power? So in physics, power is defined as the flow of energy in unit time. The flow of energy. What energy that we talk about? It is electric energy. So what units of time? It is in second. So 1 second. So the flow of electric energy flow in 1 second. Then what is the best formula to define electric energy? The best one is that P, or power, equals to Q times V divided by T. What is Q? Q is the total charge. Q is the total charge. It's measured in coulomb, symbolized as C. While V is the voltage, it's measured in volt. T is time. It is measured in second. Now I want to derive something from this formula. Q, I will separate Q and V, and I'm gonna put the T, mathematically, to Q. Now what's the definition of this Q divided by T? The total charge per unit time is called the current that we've done. That we've discussed before. So that is the other definition of current. Current, total charge per unit time is called current. I is current equals to total charge flow per unit time. So we got the simplest formula for electric power, I times V. Can we derive other formula from this basic rule? We still can. since we know that V equals to I times R on the previous formula, so we can change or modify or manipulate this rule into other symbols. So I'm going to change I into V over R. So I is V over R times V. We got P equals to V squared divided by R. This is the other derivation. Can we have another formula? Yes, we still have. Since phi equals to I times R, so we can derive I times R again. So P can equal to I squared times R. Done. So there would be three different formula for electrical power. First one is P or power equals to I times V. The second one, P equals to V squared divided by R. The third one is P equals to I squared times R. Okay, so we forgot to put the definition of P. P is electric power measured in watt. I have to tell you something about the unit watt. Watt, in physics, can be defined as joule per second. So it is connected to the definition of power, which is flow of energy per unit time. The energy is measured in joule, and time is measured in second. So watt is joule per second. So if, let's say, there is a lamp with 12 watts, what is the meaning of this? The meaning is that those lamps, or the lamp, can deliver energy 12 joules definition, and let's say the lamp is 12 watts. What is the meaning of this? So the lamp will deliver the energy of 12 joules in 1 second. So you can count for 1 hour, right? So 12 joule times 3,600 seconds, 1 hour. That is the total energy that is needed to light up the room. For example, if you need one lamp or one bulb with the power of 12 watts, if there are two different lamps with the same power, then you're gonna have a double, or you're gonna need a double energy to make it flow and light up the room. Okay, so I think it's done. This is the definition of electric power.